today's thing, we're talking about mocking here. So the way we want to run this thing, so Day is also helping me here, Rahul Day. He's also on the call. And we would be discussing what mocking is and how we are using it currently and how it can affect your design, the way you write your code, and the way you test. So the greater impact is not just the impact is not just your test, but also your code. We go into these kind of detail and when mocking is a good thing and when is it a bad thing, like establishing those kind of boundaries. And we want this to be like a session where we're discussing it and not like we're just speaking. So feel free to interrupt us at any point you think the statement we made is not correct or wrong, and stop us, and we can probably address that and see what's the issue in understanding that. Cool. Okay, I think.
Yes.
Yeah. So yeah, mocking in tests. Now, I think we as ThoughtWorkers, we do a lot of TDD, right? We do a test-driven development for anything. Before we write code, we jump into writing our tests. And when we write our tests, I think mocking comes as a natural, right? We will like, okay, we're doing TDD and we need to do mocking because the way we do TDD is something that influences the way we think about our mocking as well, right? So to get into this, deep into this, let's go into how and how we write our unit tests. So one of the approaches that I've observed with a lot of people is they use this AAA approach, which says arrange, act, and assert, which typically means you arrange. So you have a problem statement, you have a feature to create, and then you start arranging the objects that you would need, or methods or whatever classes that you need to need, and you start arranging them and preparing it for your test. And then you would act, as in you would see what happens when you act on that subject under test. So if it's basically, when I say subject under test, you're looking at what piece you're testing, right? What unit of the system are you testing? So if you have a problem, say as large as X, and X is made up of A plus B plus C, and you want to test A specifically here, in that case, you would want to arrange all the items that A would want to, what A would need. So say, A has a dependency with B, you would prepare B also, and then you would prepare A, and then you would test A. I would act on A, and then you would assert on the things that you want to assert on. It could be anything. It could be you want to assert on its final state, you want to assert on its behavior, on how it called B, or something like that. So there are multiple ways of going about this, right? If someone wants to add anything here, just feel free to pitch in. Unmute yourself and do it. Right. So that's about unit testing and how we think about and write our unit tests. Let's look at a very an example here so that we can align our heads to that. So there's this system where you have, if you see, we've written a test for something called an order, order object, and it depends on this other object called warehouse. So the order and warehouse are like two different objects. And what we are trying to test here is focus on the part which says, if you can see a mouse pointer, we're focusing on the test order is filled if enough in warehouse. Right. So what we are looking for, the subject under test here is order, and what we call a collaborator here is the warehouse, which is collaborating with order to do a certain task that we want to test for, whether this task is being done properly or not. If you see, you prepared the order object here, and then you also prepared the warehouse object here using new warehouse IMPL. And then you are doing order.fill and you passed in the warehouse object. And then you're just asserting on whether order is filled or not. Right? Imagine a Boolean thing, whether the order is filled or not. And it also is asserting whether the warehouse was emptied or not. So because the order was taken, the warehouse should go empty, right? So that kind of a relationship. So you take an order, the order picks it up from the warehouse and creates that so that it can be processed. So if you see here, the point that I want to point out here is the order is our subject under test. I'll repeat that. Warehouse is your collaborator. And if you see the style in which the test has been written, it is a state verification. We are checking on the state of order, whether it is filled or not. And also we are checking on the state for warehouse, whether it goes 0 or not, right? This is one style of testing that we use, right? So this is a very, a way where, you know, you're using plain classes to test. You are actually using a warehouse object there. You're creating a warehouse object for real. If you see in the setup phase, there is a warehouse.add, right? So you're actually creating a particular, preparing a real object here for testing order, right? So let's look at a way of doing it using mocks, right? How would you have done if you would have thought in the mocks kind of a way, right? So if you see what happened here, the things saying the setup phase vanished. If you see, instead it was overtaken by this line here, mock, warehouse mock, new mock. So what we have done is we used some kind of a mocking library here, and we mocked this particular class. Right, and then we have set the expectations. If you see, it says warehouse mock.expects. So you're preparing the expectations here for the mock. So you're saying my mock should have which has a method called has inventory. It should be called once with these parameters, which is Talisker, which is a string, and 50, and it should return a value true. So basically, this could be an internal implementation of the order.fill method that is being tested here, right? And I will use the term method and function interchangeably, so don't get confused. So so it has set an expectation for your mock. It has also set an expectation to run the .remove on warehouse object with these parameters, and that would, of course, empty the warehouse, right? So what you're doing is you're testing how the fill method is working, right? So what you did here, you gave order.fill and you're passing on the proxy object here as warehouse. So now when you run this method, it would call the mock object instead of your real warehouse object. And then it would, then you can just do a warehouse mock.verify to verify these expectations that you just set. And of course, the state here is also being tested. So if you see, when you're using a mock, you're doing much of a lot of behavior testing here, right? You're going into the method and seeing the implementation of the method, and that is also being asserted upon along with the state verification here. So this, if I go by the wording, it's called open box testing or white box testing. And the opposite would be, you know, just checking the state would be more of a black box or a closed box testing. So for reasons, I will not use the term white box and black box. I will more use the word open box and closed box. Hope that's fine. Right.
Yeah.
And now, if you see, we just saw a mock, right? Now that's one example where you saw mock working in a certain manner. Now, if you see, there is this other way of mocking things also. And here, if you see, we've used something called stubs. So if you notice the test here, which says test order send mail if unfulfilled, this is checking on whether a mail has been sent or not. And of course, in a system that you're in a test system or a test setup, you don't want to send out mails for real, right? So what you've done here is you created a stub. A stub is more like a test double. So it has the same kind of method. So if you see, it's using an interface that already exists, which you have also used inside of your code maybe. And what you've done is you use a mail service stub now, right? And then you pass that in. Now this mail service stub omits the parts where it actually sends out the email, but it sets out the state in a manner that you are able to test on it, right? Here again, you're doing like a closed box testing, but you're using a stub here, right? Not a mock, right? So now if you see what what you observed here, you saw stub being used. Now say, we use something like a mock here, like, going again in the mock way of doing things. What would you have done for mocking? So you would mock this warehouse object, you would mock the mailer object as well, because mailer has become the other collaborator. And then you set these expectations of whether, .send was called on it once or not. And so it follows the same pattern, right? We are again here testing the behavior, right? Now, what you've seen here as different kinds of mocks. So we've seen like testing behavior, which is kind of, getting into the implementation of it and trying to assert on those. And then you just also saw how we are testing on the state. Now, when you talk about mocks, the term mock is so overloaded that we miss that, we're probably not using a mock at all. So what are these different kinds of mocks? Probably I'll try to bring in some clarity here. So there are different kinds of mocks that you can use, and every type will be needed in a certain kind of a system or in a setup. For example, there are dummy objects, right? So dummy objects are objects just lying there. They're not usually, they do nothing mostly. They're just there to fill a parameter list, maybe, just to match with a particular interface, right? Maybe you are calling mailer and you don't want to test on the mailer object at all. And you just pass in a dummy. So whatever happens or whatever methods are called on that object, you don't care about them. So then you create a dummy object. Please call out and stop if you are confused here, right? Because I don't have clear examples to show you here. So it's mostly speaking. Right. So the other type of a mock could be a fake object, right? So it has working implementations. For example, the mailer object again, it has a working implementation of send, if you see here. But what has happened here is it takes shortcuts, right? It does not actually send out the mail. So that is one one kind of a mock as well. It's like a fake object. So this could also be for cases where you're trying to test databases, right? Like you need to make a database call. So there also you would create a fake object. You would not actually make a call to the database, but the fake object would just return what the ORM that you're using, the database object that you're using would return. There are other kind of mocks that are called stubs, which provide canned answers, right? They just say that, if you get this kind of a call, please return this, right? So if you see an example of that would be, this one, warehouse.expects once method has inventory with any arguments will return false. So what you've done here is you defined what you want to return. So this becomes again a stub, right? Oops. Yeah. So it has canned answers. When I say canned answers, it has template stored. Okay, if I get this, I return this. That is one kind of mocking. The another kind of mocking are spies. So spies are like observers, right? Just seeing whether a method was called or not. So if you see, again, an example of that would be somewhere here, right? So it says once.method sent. It says, I want to spy on this method called send and see whether it was called once, right? This is a type of spy. Oops. Right. And so if you see, there are these different kinds of mocks that exist. Now, every case is special. Like whenever you are writing your code, each type of mock you would want to use it is special. So then you would go pick and choose between these different kinds of mocks. Right. So from when we understood them now, since we've kind of understood what mocks are, just call it out if you've not. We want to go into this whole mode of testing, right? There are different ways to think about your testing. Using mocks is not the only way. So there are people who also are, they're called classicists, people who want to use only pure classes to test out their systems. And then there's people who go by the mocking approach. And both schools of thought have very good reasoning on why one is better than the other. So we'll go through that. Let's start with the test setup phase, right? And here, if you see the way classicists think, the people who write, who go by the class approach. So this is the preparation phase, right? You want to set up your objects here. classicists will use something called fixtures. They will create these classes that, like just like you saw, the warehouse object got created, right? In the first example. And then the mockists, on the contrary, will try to create mocks for all of this, and they will not create mocks for everyone. So say, order is dependent on warehouse is dependent on something like maybe an inventory. So that way you don't have to mock everything. They would just mock maybe warehouse. Inventory would get automatically, a mock. So because you're not testing on that at all. So they don't care about the surroundings a lot in the mockist area. And they have good reasons to not do that, and because it saves a lot of thinking that you need to do on what are the different dependencies. So that way it is easy to mock. The other thing that where classicists and mockists will differ is on test isolation, right? So for example, you write code as a mockist, right? And say your warehouse object in that example where you're testing the order object and your warehouse object is there. Your warehouse object is failing. In a mockist world, the specific order test will not fail. Why? Because you mocked the warehouse object. You're not testing it on the real warehouse. So if the warehouse object is buggy, as a mockist, you will not see that, right? And maybe you have written test for the warehouse object specifically, and that specific test will fail. And then you can go and fix that. But you will not see any kind of repercussions of the order test. On the classicist side, if I look at the classicist way of testing, what will happen here is that the order test will fail. Maybe some other XYZ tests will fail, which are depending on warehouse. So here is where the classes and mockists differ. So classes say that this is good because this is testing the complete of my system. I know which particular pieces would die if one part of my system is failing, and then and it's pretty easy to figure out which is that piece, and then we can go and fix it, and other tests automatically get fixed. But I have this whole idea of completeness. I know I have tested every part of my system. On the contrary, mockists say that, wait, here I'll be confused if a lot of tests start failing. I don't know which part is failing. I need to know which part is failing, and I go and fix that. So this is what mockists say, right? So if you see, the need for tests and the granularity changes in both approaches. So if you're a mockist, you have to be careful to test each and every part of your system as a unit test. So you need to test your warehouse object, you need to test your order object and everything, even if warehouse object is not used independently anywhere. Say it is being a dependency everywhere, you have to test that as well. Versus in a classicist way, it has already been taken care of because you're using the real object. So you don't have to write a specific test for warehouse, right? So this is one other difference in how the classicist way of thinking and a mockist way of thinking changes your tests. Now, how does it impact your code? The classicist and mockist way of thinking, right? Now, the thing is that when you think in a mockist way, you're testing mostly implementation. You're going inside and checking on expectations of whether this particular object was called with this method, whether it returned that particular thing and all that. So you're basically mocking all of that. So the real object is not doing that, but you're kind of creating a structure there and doing it. What leads to that is that you're testing implementation. You're not testing the results. And what this finally leads to is a very coupled situation, because you've not, as part of tests, you did not look at the kind of coupling you've introduced in your code. You've tried to ignore that by creating mocks, and that has a larger impact. At that moment, it feels nice and easy when you're doing it, but when problems bloat up is when you start seeing the problem instead of seeing it when you're writing tests. So I'll tell you what are certain patterns that can cause problems when you're as a mockist. So even if you're a mockist, don't try to do that, is one of the things where you're using with any arguments, right? That again becomes the crux of the problem. You're saying that this is, irrespective of what it is called with, I will just hit false. This is like a smell here. So if you call it with anything, your implementation changes. This will start. This would not. This would not be caught, rather. And if you, yeah. So these are the differences with classicist and Mockist way of thinking. Any points? Yeah.
Yeah, maybe I think in the classist way, I think the level of granularity is more, and the test whatever we write, right, it should be such like that. If we remove or edit one line of our code, the test should get caught it, like whatever you said, right? That one.
Yeah, true. So that is that, and then yeah, I think that's a fair point. Right. So here, just to add here, so if you see in the Mockist, in the classicist way of testing versus the Mockist way of testing, you will need more tests on your unit test level in Mockist because you need to have that code coverage in mind, right? But in the classicist way, probably that code coverage is not that important. So that's one difference I would like to point out.
And also, I think it will affect the design of the system. So if you're thinking in a particular classicist way, then you don't have to think much ahead of what you are testing at that particular moment. So because you will go back to that particular piece of code and you will actually write which is required. But in the Mockist way, you are thinking way ahead of what is going to be there. So this is ultimately going to affect the design of the system, and you might end up doing more, which is not required at that time.
Mm-hmm. We will actually addressing the design thing in the coming.
Okay.
One thing I can add is in the Mockist way, you are kind of not aware of changes of side effect changes. So, for example, if your stuff is dependent on some external system, if that changes, there is no way to know that in a Mockist way.
Yeah.
Because you've mocked that thing out. So that's the thing.
Yep.
If your Postgres protocol changes or your version changes, then there's no way of knowing it.
Yeah. And I think these conversations are a good cue to what we want to talk about here, how your testing style impacts design, just like people brought up.
Rahul, maybe can we say something like in the classist way, maybe the level of testing and granularity is in our hands instead of in the mocks, right? So if it's the mocks, we can't control some of things, right?
Yeah.
In Mockist thinking. Yeah.
Very well put. Yeah, that's the point. Yeah. So if you see here how it impacts your design, like we've just been talking, it introduces greater coupling because you've not been looking at those coupling problems when you're writing tests. You are later on, since you're testing behavior and implementation, your refactoring later on becomes a pain. Every time you refactor, you will have to refactor your tests as well, right? And the chances of you occurring, dealing with false positives increases, which is the bigger concern. So when I say false positive, it means that you wrote a mock and the test there has the object there has actually is buggy, but this test passes, and you have this false feeling that the order object in this case is fine, right? Which is not for real. In production, this will go and fail. Maybe somebody missed to write that particular test case for the warehouse object, and it just went into production without it breaking. So now you have a case of false positive, and it blows up in production, and that is a scary situation, right? So this is how it starts impacting your design also. And I'm saying here more result of that way of thinking has on your design, and eventually on how well you sleep at night. Yeah. So we can look at some examples here. One very specific example that you will face very commonly in code is this outside world interface. So when I say outside world interface, you're interacting with a library written by someone else from third party, right? An external library. So let's look at this example here. It's Python code here. You're using something called Boto 3. And Boto 3 is kind of an AWS SDK of sorts. So that's a library which you can use to talk to AWS services. So in this particular example here, what we've done is we've created this Arogya Setu object. and it initializes itself with name and Aadhaar number, right? And there is this method called save. It's a method on the object. That's why it has a self there. And then you can pass it the bucket name, and then that is used to call the Voto3 client here, and it's stored in S3. S3 is like an object storage system, so where you can store files basically. So you are basically storing a file which has the body as the Aadhaar number, and the file name here is the name of the person, maybe, right? How would you test this kind of a system will be the question, right? So you'd go ahead and write a test something like this. So what you're doing here is there's something called Moto. So Moto is like this mocking library for Boto. So what it is doing here is you are creating an instance of the yeah. So Moto is like it's mocking your S3, so it will not. It uses this whole stub approach where it makes, or I would say no, a more fake object approach where it is taking a shortcut. It will not actually make something in S3, but it will return the way an S3 Moto thing would respond back. And this is a situation we actually faced in our project where we used Moto to do mocking. And what happened is that this introduced a lot of incidental problems, right? We could not catch hold of problems in the system in the test phase. What happened here was that the contract changed for our Boto object, and Moto, the library that we're using for mocking, forgot or maybe were late in updating the contract. So when I say contract, the way we call this method called put_object. So that changed, and Moto did not update it, and our test ran, and this went into production, and it broke there. Why did this happen? Because Moto was not in sync with Boto. And when you're dependent on external dependencies, doing that is very difficult, right? This will break if you are doing this as unit tests. This is one problem. The other problems that arise are, say, so these AWS usually uses these kind of permission lists, right? And say your permission is missing to write to your particular bucket. Bucket would be like say a drive, maybe, right? In S3 terms, right? And then you're writing to it, and your permission is missing. That will not be caught here, right? Your storage, if there is a storage quota on your S3, that will not be caught here. So where would you want? So, and now you would be like, okay, I can't do this in unit testing. Where should I do it? So that's why these things we believe should be done more in an integration test level. So the integration test fails. So that and so in that case, you would not even need this particular test that we've written here, right? We can live with an integration test. So if you see that, you don't need to write a unit test for this. That's what we are trying to say here. Right. Do you want to add something on this?
Yeah, pretty much on the similar lines, we have a habit of, so for example, even if you don't have to go that far, for example, you want to mock a DB, we have this habit of using an in-memory DB to mock to even say. So we said that we don't want to mock, we want to use so what I want to point out is a problem in the integration test as well. Like if we use Postgres, for example, in our production, but just to speed things up or some other reasons, we want to use an in-memory database in our integration test. So for example, that H2 is one such example. So again, you want to say even if you want to write an integration test, it's more preferable to use the real thing that you are using. So use a containerized version of it, use something. So, but don't change the implementation in the integration test as well, like of the external thing. That's
here the idea being to reduce the chances of false positives, because if HT goes ahead and makes a decision to change its interfaces and Postgres does not, your Postgres integration fails, but your H2 is fine. So right, this is one example. Does someone want to add here something?
Yeah, I think we can yeah, go on.
Fine.
Yeah, go ahead. Go ahead.
Okay, so as we were talking about the database thing, like we at times we tend to use these in-memory databases like H2 or something, right? I mean, for example, in our project, we didn't have any other go rather than using in-memory database due to some infra issues. We could not use a Docker containerized version. One thing that we need to keep in mind if we are using something else is for certain aspects, the same features would not be available while that are actually available in the main database that you're using.
Right.
So when we have to test such things, we need to keep in mind that we do not mock many of the things. Like for example, if you're doing a stored procedure call, we should not be mocking the whole stored procedure in the in-memory database that you're using and try to replicate all the business logic in that, because it's actually not testing the main flow, but you're just mocking something and you're trying to say that it is working, but it might actually not work.
Yeah.
And this is like also a cue to simplify your tests. So one of the things probably Chinta will talk about later, moving the IO and side effects to the outside. So if it's just very simple, you can just call the function and test its effects. So what you're saying, Shivani, is about going into the box again, mocking particular stored procedures. So what we would recommend is just move it to a single function, just call it, test its effects.
Yes, yes.
Okay. Maybe move to the next example. Okay.
Yes.
Right. So this other example is more on the design aspect. So this is around coupling, right? So let's look at this example. This is JavaScript, and we're using this library called Axios. So Axios is this library which is used to make HTTP calls. It's like an HTTP client. You can use it to make GET, posts on all these kind of HTTP requests. If you see here, the system that we've written here does like a users.all, and where you can fetch from an endpoint called users.json, and that would give you a list of users, and you're just picking the active users from this, right? So how would you write a test for this? This is so if you would want to write a test for this, you have to use mocking here, and some kind of mocking. It could be the classicist way or the mockist way. You need to mock that out. And what we've done here, if you see, we're using something called jest.mock. Jest comes with this mocking tool set, and you can mock on Axios. So it would go ahead and mock the interfaces there. And what we've defined here is, if you see, is we've put a list of users, created that, and then we've put that as a response, we've stored it as well. And then we've said, when you do a .get call, resolve it to this particular response, right? And then you would just check on it. If I do a users.all, would I get this data, this exact data? So I would get only Bob because Alice is not active, right? So this is when you're doing a mocking. Now, how would I want to decouple? If you see what's going on here, is there is your logic lives here. This part is your logic, which you care about. And this Axios.get is like an external call. It's a side effect, as we were saying, right? So how would you separate these out, the side effects? So here, the point we're making is push the side effects that are there in the system to the boundaries of the system and pull out your logic and unit test the logic. So how does that look? What we've done here is we've pushed away all the part which is giving us or doing the side effect here, which is getting that data, that into one piece, and then we've extracted the filter part out and put it as another method altogether. So now you would do a users.all.filter active. Now you would write a unit test for this piece, the filter active piece. You do not need it for the all piece. This piece can be done using the integration test. So how would it look like? So if you see, this is what it would look like. So given this user, and when I want to filter. So if you see, I'm only checking the should filter active users part, nothing else, the filter active users part. And the rest of the part can be taken care of and an integration test. So how would it look like? Just imagine that you can just pop up a server, proper HTTP server, and that would return this particular JSON file. So here this is basically like having those fixtures in place, that particular server returning these requests. So it has to be external from the system. It should not be inside part of the system. Yes. Anything someone wants to add here?
No.
Okay. I'll take that as a note. Yeah. Yep. Cool. So yeah, one of the ways to reduce all of this is we've observed is using composition. So and this is to reduce the specific problem of coupling, which will eventually impact your test. So there are some ways of what is composition and decomposition? Composition and decomposition is mostly where you are taking a bigger problem and breaking it into smaller pieces with which follow the pattern of do one thing, right? My method does just one thing. So when you've done this decomposition, what we are saying here that if you really need mocking in your tests, we are observing that your decomposition strategy has failed. Maybe you were not able to decompose it properly, right? So, and that is the reason, you are being pushed to mock things. So I think taking a step back from it and looking at your whole design and not just a test or subject under test itself is what we want our visibility level to be at. And that's when we will start seeing the problems of coupling. That's when we will feel, okay, I think things are very tightly coupled. I need to disconnect these things, right? So there are many strategies to do composition. So one of them is in the functional world. They use functional composition using higher order components. They will just wrap it one over the other. The other way is using the Redux model, where you store the state in a particular place, and then you have these reducers which work on them. That is one other way. And then there is this object or factory composition also that basically are like mix-ins, right? So these are some ways that we can use to compose things, right? That is one way. Like we said, right? We're trying to reduce coupling, and what does coupling look like, right? So to get into that point, what does coupling look like? One way of one thing that you can look at is, are you doing inheritance, right? If you're doing inheritance, there is clear coupling, right? Are you using global variables? Is there a state lying around, right? Are you using a mutable global state, right? Maybe something like a DOM. Is there shared storage? These are again examples of coupling. If there are, yeah.
I can add one more thing to the dependency injection was introduced as a way to reduce coupling, but if you think about it, it's actually increasing coupling.
Yes, yeah, I was getting into that point as well. Yeah.
Right. So we should be judicious about using dependency injection as well.
Yeah. So dependency injection in different forms as parameters, or as even containers, both forms. And also, if there are any imports which have side effects, that would also is also a smell, right? That there is coupling there as well. We're not saying coupling is bad, but avoid coupling as much as possible. And then, there could be implicit dependencies, and there could be, parameters that are mutable. So there are these other huge list of things that can go wrong, right? So let's look at one other example here. Let's try to test an Express app, right? Your task is to test an Express app. So you wrote this app here. It's pretty neat. I'll just explain the code for people who are new to Express. So what I'm doing is I'm importing this library called Express. That gives me an Express server, and it gives me this interface that lives inside of app. And when I do an app.get on this and I pass it the route and a function handler, it will, and then you do an app.listen, and then it starts up the server. And then if you do a slash on 3000, localhost 3000, wherever you're running it, it should respond with a hello world. Now you want to test this. The general thing is that how do I test an Express app like this, right? And how do I test this whole file? Will I, will I be able to get 100% code coverage instead? So you would go about writing a test for it, and which will probably involve you to do dependency injection, which we talked about. It will involve you to try to mock this Express app and try to test it inside its internals. What we are saying here is, if you see this particular file does not need testing at all. And even if it does, you can break it down into pieces. How would you break it down into pieces? You would do this, right? So what you did here, you created this hello function and you put it into another file and you unit test this file, right? Then you have this handle listen, port and log, and that again, you put it out another function and you will test it out. And what will the implementation look like? It will be this particular method that you're seeing, this function and this function. And you can test that independently. And then you have everything here. Now this file does not need to be unit tested at all, right? Now the only way you want to test here would be, how would you, because there's no logic as such here. There's no logic here. It's all just calling the interfaces one after, there are calls one after the other. So the way you would want to do this is to use integration tests. So this would need a good 100% integration test, if not a unit test, right? So does someone want to?
We have 2 minutes remaining.
Sorry?
We have 2 minutes of time remaining calling it off.
So, feel free still to add. What we are saying at the end of this is mocking is not evil. It's not bad. We're saying it, we have to, it can be dangerous to your design. So be careful when using them, right? And use them as much as possible, and use like more doubles, test doubles than real mocks, and like that Dave was pointing out, use Postgres database instead of the H2. Use real test doubles, right? So there are some principles that we came out with when thinking about mocking. One of them that we've been saying is, fight your urge to mock in your tests. Fight it as much as you can. That way, you will start thinking about bigger problems that will put you in the path. Second, just hold your thoughts. If you want to add something, I'll go through the whole list and then we can talk about it if we have time, so that people who can drop off can drop off. Right. So use test versions of external systems integration tests, like the same example that Dave was giving. Push your side effects to the boundaries of your system. Try to push them away from your actual system and your real business logic. Don't take coverage as your holy grail. It does not tell you that your system is completely fine if you have 100% code coverage. Rely on your integration tests to give you your peace of mind. Reduce your coupling. Again, going back to the design. If you reduce coupling, there's a chicken and egg effect here, basically. Your coupling, reducing your coupling will reduce your need to use mocks. So it's both ways, right? Yeah, I think that's it. That's it. So what I'll do is I'll stop sharing here, and let's talk about, if you have time, you can stay back and we can talk about more about this topic and what things you thought about here, and your experiences. Mala wanted to share an example that they are doing right now in their project. Yep. Mala, you want to share your example that you were talking about in the beginning of the talk?
Yes, actually we are facing some issue while mocking, means it's not mocking properly. We don't know why.
Can you explain what you're trying to mock here? Maybe that we can use that as an example.
So we are trying to mock an Firebase library, which actually we are using for sending notifications for mobile. Maybe Afrin can explain it better rather than me. Afrin?
Maybe I'll try before you can come in. I'll try to rephrase what you said and see whether you understood it. There is a system that sends notifications from Firebase, and there's maybe some notifications you store in Firebase that comes from other systems, and the Firebase system triggers notifications.
I think this is more on front end, right? On the mobile app, right, Mala? This is not on the back end.
No, it's not on the back. It's
Yeah.
actually on the back end, sorry.
Oh,
So there is a Node.js server where we are getting a notification from some other server. We need to fire that notification to the mobile app.
Sure.
We are catching that. We are doing that, but the tests are
okay. Usually mocking the Node.js in the Node.js environment, if you're mocking actual node module, usually based on your test framework, if you're using Jest, usually it provides that __ kind of mocks folder. So if you put some implementation over there, it should be picked up from that folder. That is what Jest does it. So based on your test framework, you can.
We are using Jest.
Yeah,
so
sure.
It's like an function call in a function call in a function. So yeah, just.
Okay.
What is the subject under test here, Mala? If I may ask, what part of the system are you testing?
So we are getting a payload from another server, right? So we are just testing whether it's getting processed correctly and it's expected notification object which needs to be sent to the mobile is called correctly or not. Yeah.
So basically you're trying to test the body of the payload, right?
Yes, body of the payload and it's getting called or not.
So I think a fake object of Firebase would help here because you don't actually want to send the message, right?
No.
So I think the fake, because I have been using this to, actually I'm using it in Firebase database. So I do not actually want to call the database methods, but I want to see whether that particular object is getting called in my lifecycle or not. So for that, what I did is I mocked the Firebase object, like not mock, I actually created a fake for that Firebase object, which is actually implementing all the methods, but I only check whether the payload is fine or not inside that particular fake. And if it is not the way I expect it to be, then I send error or something like that. So that's how I'm doing it. So far, I have not faced any side effects or other issues with this.
Okay.
Yeah. So you can try that approach.
Yeah, we'll try that, Varun. Yeah.
I think here you can actually, Mala, we can distribute this whole testing here, where you can have a system in your test where you're only testing your transformation of the state. So you're getting some notification in some form from some system. Then you are transforming it into something else for your other notification system to probably understand, right? So this transformation piece is your main business logic.
Yes.
So you can isolate that without the side effects. When I say side effects, where it is collecting from and where it is pushing to. So you just isolate this part of your code and only test the transformation. So if your transformation of the data from this form to the other is fine, that would make sure that your business logic is completely okay. And then over that, you can write some kind of an integration test, maybe, to test this whole system of coming in, business logic being applied,
and then it's
the push being.
Yeah.
You could think about it in this manner.
Hey, this is Sharath. So I agree with Varun. So that's also has been my experience. Your earlier example of the S3 code that you're showing, right? Where when you save something, it directly uses that object to save it. There is this principle of separate use from construction, wherein you don't create the real dependency. So that S3 kind of client library is providing some kind of interface for you to put an object, right? So I also had a question on the dependency, but assuming what I was saying was right, or what the approach I was using is, you inject a dependency which conforms to that interface or protocol, and then you just say put object on that. That way, when you use a fake or something, you could also simulate situations where it throws an exception or raises an error, where it is a connection issue or all those scenarios, right? Where the bucket is full and all those things. That way you could test all of those. And the actual one, probably through integration tests you could do. I don't know if I made sense. So I'm kind of trying to use dependency injection to inject all the dependencies, use some kind of an interface, and then inject the fakes in the tests and push, kind of the actual implementations of the real objects only happen through integration tests.
Yeah, I was also trying to say the same thing, because I'm using TypeScript, so I usually work with type, so I have that particular interface always there. So if you're working with JavaScript, then I think you will have to create some kind of wrapper or function, as Rahul was mentioning. So yeah, but the approach will be somewhat same.
Right. So even in some cases, you may not have an interface. For example, one example I do. So in iOS, I was doing an iOS app, and there is this address book library that Apple provides where you have to pull up a contact. And in some object where you try to send him an amount or something, you look up this phone number on the address book, and if is an entry, you actually show his name. Okay. So you're kind of dependent on the address book. But what we do is, if I directly use the address book API that Apple provides, I can't mock it. I can't replace with a fake one. So I know these are address book class provides this 40 different APIs, but I'm not using that. I'm only using 4 of them. So I create a protocol or an interface which only has those 4 of them, and make that as a dependency, and make my address book object also conform to that. I mean, it anyway conforms to that because I'm just copying that API and making a subset of that into a protocol.
Yeah.
Right.
Yeah.
So,
yeah, something like that. Yeah.
I'm seeing with that is this interface is defined actually by the external library, right? Which you have no control on, and you're doing it when you're writing your code. Now, tomorrow, if that interface changes, right, the contract changes, you will not detect it in your tests. It will go and fail in production.
Right. True. But wouldn't you hardcode your versions dependencies in whatever your dependency file is? For example, use Carthage, but whatever, Gradle, whatever the dependency library, right? You lock the versions. That way, you're safeguarded against that.
Yes.
Yeah, I think what Chinta is saying is the implementation of your fake interface that is not in sync with the. For example, if this goes and calls something, so probably you wouldn't have looked into the real implementation of the real object, and you have faked it, and probably you missed out some checks regarding some file permissions or something.
Yeah, that is one thing there. I'm also pointing at the other point here. Say, you get something. There's something called dependabot, right, which checks for your whole. You wanted to upgrade your thing or not. Like if you want to upgrade your libraries or not, right? It gives you a PR or something. It creates something. When you want to upgrade one of your library, and you say that I upgraded the library and my tests pass.
Okay.
And this is very much possible if the library got upgraded and your tests also pass, because you have that fake, which conforms to the older interface, and your code also conforms to the older interface, whereas the library's interface has changed. Now, when you push it to code, it breaks in code. This is a scenario that I am pointing at.
Yeah, true. In such case, probably integration tests would only catch that.
What I'm saying is, if you have this address, like you said, the address API call on the Apple thing, right? You have these kind of calls, push it to the boundaries of the system. Don't call it inside one of your business logic thing, right? And then test it. So you don't have to go ahead and mock it in your unit tests. Instead, you can be happy with your integration tests that will catch these kind of problems.
Yeah, kind of makes sense. Yes. If you kind of map this to that hexagonal architecture or ports and adapters, you're kind of saying this needs to go to the boundary, and it's not the core, it's not the application layer, it's just this final adapters that sit outside the boundary, I mean to the boundary, right?
For example, you would still, the interface would still help in the sense to change the connection, for example. So where interface helps for me at least, I do a lot of Clojure and maybe a bit of Elixir as well. So there you can just point it to a different connection, which is the same DB, but the port is different because this is a test DB. So that's where the interface is still helping, just the constructor part.
Yeah.
Sure. The other thing was the classes. I don't know. So I understood kind of the hint was favor the classist approach more than the mock kind of. But the problem with this is you have to test in isolation and all that. So when you do the classist approach, you are actually using fixtures or object mothers to create the real ones. So you kind of exercising the real objects everywhere. Wouldn't the test be slower because as a consequence of that?
That is true. That's a point that is usually brought out by Marcus as well. That this happens, but what I'm looking at is the trade-off here, right? What is a bigger cost for me? Breaking in production versus, my test running a little slower.
Yeah. The other problem was if A depends on B, B depends on C, C depends on D. There's the bug in D will actually fail tests on D, fail tests on C, B, and A. So I have a lot of failing tests for some bug somewhere, right? That is also
Here the problem is the coupling again. Then.
Okay. Okay. Now then, yeah. So what you are saying, actually, if I read it right, the underlying current, I think this whole O approach is probably not the right way. We should go functional there. Because O by definition is set of series of objects communicating
This is why we're trying
each
to point
other.
out the problem with the dependent transactions, like everything is.
Yeah, right. Yes.
Right, Chinta, we have our next call.
2 minutes. But feel free to ping us and we can have more conversations on this. Yeah.
Okay, great. Thank you. Thank you, folks.
Thank you.
Bye-bye.
Bye-bye.
Bye.